Welcome to this video lecture series on transportation engineering. In this session, we shall discuss on the joints in the rigid pavements. Now, as far as the cement concrete pavements are concerned, the joints are joint is a very important component because it has to perform various functions. The main purpose of the joint is to relieve the part of the stresses which will be developed due to the temperature variation in the slabs. As we know that these rigid pavements, they are being constructed with the huge quantity of the concrete, cement concrete. Hence, the heat which gets generated within the concrete at the time of its laying or the casting of the concrete for the pavement, and again the temperature variations which will be caused into the slab during the daytime and the nighttime variation of the temperatures. So, in order to relieve from these temperature stresses, the joints, they play a vital role. The joints in the cement concrete pavements, they are, first is the longitudinal joint, and second B, it is a transverse joint. So the first case, the longitudinal joints, they run throughout the length of the rigid pavements, and in the pavements of the width of 4.5 meters, they are needed to provide a longitudinal joint. The need of these longitudinal joints will be to prevent the shrinkage cracks which are happening or which are caused due to the initial period of the curing, that is the heat of hydration, which will be generated when the cement it comes in contact with the water at the time of the casting of the concrete on the site. However, as the lane width when it is generally within 3.5 meters to 3.75 meters, then the longitudinal joints are provided between each traffic lane. Here, we should note that the shrinkage cracks, they develop in the slabs whose width or length is more than 4.5 to 5 meters. Next, the longitudinal joints, the tie bars in the longitudinal joints, the tie bars, they are provided along the longitudinal joints in order to prevent the opening up of the longitudinal joints in the due course of time. Now that can be under the influence of the temperature stresses or the temperature variations, the loadings of the vehicle, etc. And these tie bars, they are having the specified diameter and length which are placed at a specified spacing at the mid depth of the pavement slab. That is, these tie bars, by the name itself, they tie the two slabs of the pavement in the longitudinal directions together. So the function of the longitudinal joint. The longitudinal joints, they function as the contraction joints and prevent the development of the additional shrinkage cracks in the longitudinal direction. So as you can see from the figure, we have this longitudinal joint which is provided throughout the length of the pavement in the concrete slab. The wrapping joints and relieve part of the wrapping stresses. So the wrapping action which basically happens just because of the temperature variation. This longitudinal joints, they also relieve the part of this wrapping stresses, and it also provides the lane markings in the highways with with more than two number of lanes. Next is the transverse joint. The transverse joints, they are they are again subdivided into the three categories based on their purpose. First one is the contraction joint, second is the expansion joint, and third is the construction joint. So the first case regarding the contraction joints, these contraction joints, they are formed by cutting a groove into the concrete slab at regular intervals. The width of this groove, it should not be less than 3 mm, and the depth, it should be within 25 to 30% of the pavement thickness. The spacing of the two contraction joints, it should be at 4 to 5 meters. The shrinkage cracks formed below each of the groove at the weak end section during the period of curing, during the initial period of the curing. Anyhow, these shrinkage cracks formed at the regular intervals to prevent those cracks, the contraction joints they are being provided. So whenever the casting of the concrete is done, once the concrete it gets set, it starts to shrink. So this shrinking of the concrete, it will lead to the formation of the shrinking cracks. So this provision of the contraction joints, they will reduce this formation of the shrinkage cracks in the concrete. Next is the contraction joint. From the figure we can see the cross section of a contraction joint. Here the cut is provided with the least thickness of 3 mm, and a filler material is induced in order to resist the dirt or any blockage material to be percolated down into the groove which has been provided. Again, a dowel bar is being provided at a depth of h/2, that is the mid of the pavement, in order to bind the slabs together. The length of the slab in order to resist the flexural drag, that is the spacing of the contraction joints, LC, it can be calculated as 2 into 10 raised to 4 into SC upon W multiplied by F, where SC, it is the allowable stress in the tension in the cement concrete and is taken as 0.8 kg per centimeter square, whereas W, it is the unit weight of the concrete, which can be taken as 2400 kg per centimeter cube, and F, it is the coefficient of the subgrade friction, which can be taken as 1.5. The steel reinforcement, it can be used, however the maximum spacing of the reinforcement of 4.5 meter is given as per the Indian Road Congress. Next, we shall discuss on the expansion joints. Now, the cement concrete slabs during the summer season, they actually get expanded, and during the winter season they get contracted. So in order to accommodate these variations in the length, the expansion joints, they are provided in the transverse pavement and along the suitable intervals. These expansion joints, they are formed as thorough joints across the full depth of the slab with about 20 mm gap in between the two slabs. And the expansion joints, they are provided after a number of the contraction joints. The width or the gap in the expansion joint, it depends upon the length of the slab. Greater the distance between the expansion joints, greater will be the width of the gap for the expansion. The use of the wide expansion joint space, it should be avoided, as it would be difficult in order to keep them properly filled in when the gap it widens during the winter season. The dowels would develop the high bending and bearing stress with the wider openings, so it is recommended not to have the high gap more than 25 centimeter in any case. The Indian Road Congress, it has recommended that the maximum spacing between the expansion joints, it should not exceed 140 meter for the rough interface layers. Now, if delta, it is the maximum expansion in a slab of a length of Le with the temperature rise from T2 minus T1, then in this case delta, it can be calculated as equals to Le multiplied by C multiplied in the bracket T2 minus T1, where C, it is the thermal expansion of the concrete per degree rise in temperature. The joint filler, it may be assumed to be compressed up to 50% of its thickness, and therefore the expansion joint gap, it should be twice the allowable expansion in the concrete, that is 2 into delta. So from the relation given above, if delta is half the joint width, then the spacing of the expansion joint Le, it will be given by the formulae Le equals to delta upon 100C multiplied in the bracket T2 minus T1. Next is the construction joints. Now, it is not so that whenever a pavement or a road it has started to be constructed, then the entire length of the road will be constructed in one single day. Hence, these construction joints, they are to be formed due to the gaps which will be formed in between the continuous construction works. So during the construction of the cement concrete pavement, when the concrete it is stopped at the end of the day, then the concrete paving it is suspended and a construction joint it has to be formed, or it has to be provided. So this construction joint formed across the it is formed across the pavement about its full depth, and it is necessary to provide the dowel bars across these joints for the load transfer. And to have an excellent construction joint, it is better to make it as an expansion joint or a contraction joint if it is possible. So with this, we come to an end to the various sorts of joints in the pavement. So we shall stop here. Thank you.